we'll be looking at what calculation of pH of weak acid and what base. I want to solve questions like this, more complex one. Now, but before you go into that, I want you to understand that calculating what the pH of a strong acid and a strong base is totally different from the calculation of what weak acid and what a weak base. Now, the main reason is because now when you ionize strong acid or strong base in water or you dissolve it in water, it ionizes completely. So strong acid and strong base do not have Ka or what Kb. You get now, but a weak acid when you ionize them in water, it dissolves partially. You get so for every weak acid and weak base, we have what we call Ka and what Kb. You get so now let's look at what acid. Imagine you have like this Ha as a weak acid. Now when you ionize it in water, yeah. So according to what the postulate concept of acid and base, an acid donates a proton, while a base accepts what the proton. Because this is what is my acid, and here is what is my base. So now when you accept the proton, then come out H3O plus what A what minus. This guy have what have give out the proton here. So when if you should write the expression, the Ka expression for this reaction, you're going to what K. Remember, here is an aqueous. Here is what liquid. Here is what aqueous. Here is what aqueous. So going to be Ka equals to what concentration of H3O plus. You have A what minus over what Ha. Remember, this one is a liquid. You don't normally use it. You get so this first you want to do here. Now you need to what use a ice table to get your calculation, but there's a simple formula which I'm about to give to you here. Ka equals to what S squared over what Ha. You get now here is what is the ionization constant for what for the acid. Here is what is the concentration of the acid given to you in the question. And what I'm going to do my x, but I'm talking about acid. My x is always equal to what concentration of what of H2O plus hydronium ion. You get so let me say that I want to use this formula here. I want to use this formula here to calculate what my x, and my x represent what concentration of what of the hydronium what ion. Once I get my x, is now you now take this from here. I can now easily apply this formula which is called pH equals to what minus log H2O plus. Do you understand? So this one here, we are making of it. Okay, sorry. So do what you are now going to use in the what pH calculation after you have got it from here. So this one for the weak what acid. Now as we have for weak base NH2 plus what H2O. Remember now water we act as a base here, right? Water water we act as a base. So what I'm doing to what a proton to this guy to form what NH4 plus or OH plus minus. Yes. So if you write the KB expression, it will be KB equals what? Concentration of NH4 plus your OH what minus over what? NH2. Now we can apply a simple formula that says KB equals to what? S squared over what? NH2. You get so since I'm looking you can take about the base. So my S is always equals to what? OH minus concentration. Hydroxide ion concentration here. So once I look for my X, right, I can easily what calculate what my pH. Remember, if ever I need to calculate the pH of this acid phase. Oh, sorry, I need to calculate the pH of the base. So that will be pOH equals to minus log OH minus. Do you get? Now, after getting my pH, I can use this formula here. Remember, pH plus pOH equals to what? 14, right? Make the pH formula here. You have pH equals to what? 14 minus what? pOH. You get? So you can see that the Ka and Kb formula almost look alike. A equals to what? S squared over what? Acid consider of the acid. Do you get that? Where S equals to what? Where S equals to H3O plus. For you, I can easily get your pH equals to what? Minus log H3O plus. Do you get that? Now for the base, KB going to be S square over what? Base, construction of the base, right? So my X is always equals to what? OH minus. Do you get that? Now, from here now, I can easily get what my pOH equals to what? Minus log OH minus 3, right? After that, after that, I can easily get what my pH equals to what? 14 minus what? pOH. So this is how to calculate what the so this is how to calculate pH of what? Weak acid and what? And weak base. So now let's start solving that question there. HC2H3O2 is what? Is ethanoic acid equals to 0.075 molarity, right? Now they give us our Ka equals to what? 1.8 exponential what? Minus 5. Do you get that? That's the work of the pH. Of course, we need to work calculate what the hydronium ion concentration first. So here I say calculating H3, sorry, H3O plus. You get. So I want to use Ka equals to what? S squared over what? On acid which is HC2H3O2. You get that? So remember my S is equals to what? H3O plus, right? So what we want to do now is to impute our value. So I'm going to put it here, right here. So my K is what? 1.8 exponential what? Minus 5 equals to my X now. S squared over this one given to me is what? 0.075. So cross multiply S squared equals to what? 1.8 exponential minus 5 times 0.075. 1.35 exponential minus what? 6. Minus what? 6. So this my S squared. This is what my S what squared. Now what you want to do now is what, tell you what the square root of what of both sides. Remember we are calculating what X, not S squared. So for me to get my S, I'm not to tell you what the square root of both sides equals to 1.162 exponential what minus 3. Get that? So this now going to be what? So this is now going to be what my X. Remember I told you my X already equals to this one here. H3O plus concentration. So my H3O plus number to be 1.162 exponential minus what? 3 molarity. Remember, it's going to be in molarity. So for you now, I can calculate what my pH. So pH equals of minus log H3O plus. So if you impute the value here, pH equals to what? Minus log 1.162 exponential minus 3. pH here equals to what? 2.934. So that is the what? That is answer. Do you understand? So let's look for what? Look at what the second question for what? For base. Look at what is the pH of what? Of a 0.25 molarity NH3 solution. Now, here now we are giving what the Kb of the reaction. You get the Kb of the reaction. So now the reason why they gave Kb because the base is what is a weak base. Like what I told you, every weak base must have what ionization constants. You get so which is this one here. To calculate this one here, we use our simple formula to solution. So what you like add the parameters here. Now they are asking us to look forward the pH, right? Now they gave us the concentration of NH3, which is 0.25 molarity, right? What they give to us here. Then our Kb was given to us to do 1.8 exponential minus 5. So you're going to have to use that simple formula I've given to you. So remember I told you that uh, uh, Kb equals to what? S squared over what? NH3, right? And X is always the concentration of what? OH minus. Yes. So now I want to calculate it. What I want to do here is to what impute my what kb value given to me. So now it will be 1.8 exponential minus 5 equals to what s squared over this one given to me is what 0.25. You understand? So when you cross multiply now, that would be s squared equals to 1.8 exponential minus 5 times 0.25, 4.5 exponential minus 6. Remember, we are looking for the square, the x, not the square root. So it would be s equals what? Square root of what? 4.6 exponential minus 6. 1, 2, 1 exponential minus 2. So that will be what my x is equals to what? OH minus constitution, right? So it means that I've already calculated what my OH. So the first one I want to do is to calculate what my pOH. pOH equals to minus log OH minus, right? So I want to impute some here. Sorry, S equals to this one, and this equals to 2.121 exponential minus 3. So what I want to do here is to impute your value. If you impute your value here, we have pOH equals to minus log 2.121 exponential minus 2. pOH equals to 2.67. Of course, this is now what now going to be what like pOH. That because they say she will calculate what pH, right? pH equals to what 14 minus what pOH, right? So what you put that one here, say you have pH equals to 14 minus 2.67, 11.33. So that is what the answer. Do you understand? So I want to look at on that one. So how do we solve this question here? How do we solve this question 2? What is the pH of a 0.40 molarity ammonium chloride solution? Here, they gave us our Kb. They gave us our Kb to be what? Kb of ammonia is what 1.8 exponential what minus 5. This is an acid. Yes, this one is an acid. So remember, when you react NH4 plus what H2O, what will happen here? This guy is my acid here at what as the base, right? An acid donates a proton, while a base accepts what the proton according to what postulatory concepts. So how many hydrogen do we have here? 4. If you lose one hydrogen, it's now going to be what? NH3, right? Plus. Now this guy have accepted the proton, now going to be what? H3O plus. You get. So we also have this one is what is acid. Now, if I want to calculate get the pH here, we have to look for what the concentration of the hydronium ion concentration, right? And I want to use this formula K equals to what S squared over what concentration of what of the what acid given to me. You get. But the problem is that our Ka was not given to me; it was what our Kb. So which one are we going to use now to calculate our Kb? Now we have a simple formula here that link Ka and Kb. Ka dot Kb is equal to Kw. Kw is what is the ionization constant for water. Do you get that? And Kw at a specific temperature now, the one you are using mostly is what Kw equals to 1.0 exponential minus what 14. So this value for what Kw. Get this value for Kw. This is what is value for what for Kw. So in the sense that for me to work, calculate my Ka because without the K, there's no way I can solve that question here. So my Ka going to be what Kw over what 1.0 over what K what B. Do you understand? So it's now going to be my Kw is what 1.0 exponential minus 14 over my Kb is given to me right? My KB is what? 1.8 exponential what? Minus 5. Do you understand? So there is my Ka now 5.56 exponential minus what? 10. 5.56, right? Exponential minus 10 equals to the what I'm looking for, s squared over nh4 plus given to me as 0.4, right? So you want to multiply s squared equals to 5.56 exponential minus 10 times 0.40, 2.224 exponential minus 10. So take square root 2.224 exponential minus 10, 1.491 exponential minus 5. So then going to be considered of the what equals to 1.491 is 5 molarity. This is not the value yet. So how do you calculate our pH? Remember the stage will calculate pH. Another question they will ask you here: what is the ionization percentage ionization? You get, so you use that one. It's very easy. Now after the stage calculate pH, they can also ask you what the what percentage what ionization. We're going to solve that. Yet. So now from the calculation here, my constituent of H3O plus is what? 4, okay, 1.49 exponential minus what 5, right? Now, how do you calculate our pH? My pH is equal to what? Minus log H3O plus, right? H3O plus. Just for you to include the values there. pH equals to minus log 1.49 exponential minus 4.83. So you can see how easy it is. So let's go on here. What about percentage ionization? Percentage ionization. What is it? Percentage ionization is what? Is what? Concentration of what? Of H3O plus over what? Concentration of the acid times 100 over what? Mole. It is for base. It is for base. Going to be percentage ionization equals what? OH minus over what? Of the base. Percentage ionization in this question equals to be, now remember the value of this one is what? 1.49 exponential minus 5 over what? Acid is what? 0.4 times what? 100 over 0.00 what? 3725%. So that is what? That is the answer. So we are done for today. If this video is helpful, please give it a like and subscribe to the channel if you have not done that. See you in the next video.